The principle of animation that we're going to be looking at this week is called the principle of timing. And timing is all about the distribution of our drawings along our animation timeline to recreate the illusion of changing speed. Now, I know this is some pretty big level stuff, and we're going to break it down into a series of smaller components to help you understand specifically how this illusion of speed and specifically how the speed changes inside of our animation. To start off, let's look at this simple little animation. Now, it's just an animation of a line going from the left side of the screen all the way to the right side of the screen. I've gone into my object data and I've changed my onion skinning parameters so that I'm seeing basically every single frame in the animation. So 24 before and 24 frames after the current location of my playhead. Let's just play it, see what it looks like. And there it goes. So this is what's called an evenly spaced animation. If you look at the illusion of speed that this little blue line has created, it's an illusion of an even speed. It's not changing its speed. It's not going faster or slower. It's kind of going the same miles per hour, if you will, across the entire black line. It's not changing its speed. It's not going, there's at no place on the line is it going slower or faster. It's evenly going from the left side to the right side. If you look very carefully down here in my timeline, on this green line here, I have a keyframe on every single frame. So it's interpolating, if you will. It's animating across every single frame in the animation itself. So there are 24 frames, and there's 24 lines, and you can see them with the ghosted onion skinning up, that they're all evenly distributed. And what this produces is a very flat animation. There's no sense of speed at all. If you look at the way human beings move, or anything moves for that matter, there's always these small little changes in speed that happen throughout the entirety of their animation. If you analyze movements very directly, you'll start to see these speed changes almost immediately, and then in the absence of these speed changes, our animations tend to look incredibly robotic, and this is a really great example of that. It almost looks fake because it's just evenly going from the left side to the right side. That's not how real world works. That's not how we move. That's not how things move out there in nature. There are these small, subtle changes in speed as the animation goes across its movement characteristics. Now let's stop the animation for a second here and activate an alternate one, and I've called this one in my little project file slow in and slow out. Now, fundamentally, it is the exact same animation. I want to turn off the even timing animation layer just for a second here, and I'll play it just so you have a frame of context as to what we're talking about. Now, if you look at this one, now there's a small, subtle little change in the way that this little blue bar is traveling from the left side to the right side. It's slowly beginning its movement. It's moving fast in the middle, and then it's slowly concluding. It's ramping down its speed. It's as if we were at the beginning of the animation, way out over here. It's slowly starting the engine. The engine gets full speed, and then it slowly ramps down. This feels a little bit more natural. It feels believable because we're starting to apply this idea of timing, the spacing of our drawings across our animation timeline to give us that illusion of speed. Now, if we look at I'm going to put my playhead back on frame 1 here. If you look at the way that I've actually drawn this, you can start to see how the distribution of the drawings creates this illusion of speed. I'm still working on an animation timeline here that's got 24 individual drawings. I got 24 keyframes across 24 individual animation frames, and but it's the distance that the bar is moving in between the frames that's giving this illusion of a speed. Now, if you look very carefully, I'm going to zoom in so you guys can see this a little bit more. Let's get it going here. Pardon the dust. There we go. Okay. So now, if you look at the way that I've animated this, check it out. On frame 1, the bar is here. But on frame 2, here's a great little keyboard shortcut, by the way. If you hit the up and down arrow on your keyboard, you're in advanced forward and backward, one keyframe at a time. So if I look at the distance the bar travels between frame 1 and frame 2, it's very small. It's a very small distance. If we look at frame 3, the distance grows ever so slightly. These overlapping locations is going to create this small, subtle illusion of slowing down. So when our animation frames are tightly packed, when the distance the object travels is very small in between the drawings, the illusion that we create is an illusion of slowness. In comparison, if we were to go forward a little bit, here I am on frame, what is that? Frame 10. Look at the distance the bar travels between frames 10 and 11. That's a pretty huge distance. So the illusion that we're going to get here is something of much, much, much higher speed. So when our animation frames, when our objects within our animation frame travels a small amount of distance between each animation frame or between the drawings, we get slow. When the distance increases between the drawings, we get the illusion of something that's going much faster. Okay, let me zoom out just here a little bit. And if we zoom, there we go, something like that. Now, let's return to the beginning of the playhead. And now you can see it. Slow in the middle, fast in the center, slow at the end. This is an idea that can be superimposed upon so many animations. In this week's homework assignment, you're going to be doing the screen direction assignment, which you're basically going to be animating an object doing this, going from the left side of the screen to the right and back again. By adding these small little changes in timing across the entirety of our animation, we're going to create an animation that begins to feel a little bit more realistic. In addition, for our pendulum swing, for our homework, same thing, right? When the pendulum swings along an arc, left and right, of course, there's going to be an attached center point, a fulcrum, but at the top of the arc's way over here, it's going to be moving slowly, and then the bottom of the arc, where the ball would be moving the fastest, it's going to be the spacing in between those animation frames is going to be much, much more significant. So this idea of timing is an important one for us to draw focus to. This is almost, to a certain degree, the foundations of our animations as a whole. This small little subtle spacing differences is going to create such a wonderful illusion of speed. If you look at these two animations at the same time, you can start to see this illusion just so wonderfully. They both start and end at the exact same time. They both start their location and end their location at precisely frame 1, and again, precisely at the last frame of our animation. But look how quickly the top bar kind of catches up, if you will. Yeah, the bottom one's way off ahead because it's evenly going. It's traveling the exact same speed across its entire animation. But this one, we start slow, but then in order for us to end at frame 24, it's got to go faster in the middle and then slowly ramp down. This illusion of timing just makes our animations begin to feel more realistic, and it adds that small illusion of gravity. It adds the illusion that there's some other force that's pushing and pulling against our drawings to make our audience believe that they've come to life, that they are in fact quite magically alive in front of us on the page itself. So please use this idea of timing in all of our animations. I think you're going to find that it's an easy way of achieving that grand illusion of life.